Morning, everyone. We have been discussing about the CPU scheduling algorithms, and today we are going to talk about the round-robin scheduling algorithm, which is one of the most important algorithms in the operating systems. So let's try to go and see how this round-robin scheduling algorithm will work. If you try to notice here, the given criteria to solve this numerical for round-robin scheduling is to use the time quantum. So here, the time quantum is defined as Q equals to 2. So what I mean by Q equals to 2 is like the CPU will be executing each process for 2 seconds. And if the process does not complete its execution within this 2 seconds, then that process will need to wait in the ready queue and then again come back after all the processes gets executed. So in this way, you are giving a lot of response to all the processes in execution. So let's try to see how it works. In the round robin, what I suggest, you always try to maintain 2 different queues for convenience. So the one queue that you maintain is the ready queue, and the other one is the running queue. Now, if you see in the ready queue, so at 0 interval of time, suppose if you want to run at 0, so you see that 0 process P1 is already available for running. So we bring it to the ready queue. And from the ready queue, we will bring that process into the ready running state and then try to execute it here. How long will you execute the process? The process P1 requires 5 cycles for execution, whereas the quantum given is 2. So we will only run the process P1 to 2 units of cycle. So when you run the process for 2 units of cycle, you will observe that between this duration 0 to 1, 0 to 2, you have at 1, and at 2, you actually have 2 of the processes that have already arrived in the ready state. That is, P2 already came, and after P2, P3 also came. Okay. Now, after this P1, so since P1 got executed for 2 units of time or 2 seconds, so but still so it executed for 2 seconds. So the remaining time it needs to get executed is 3. So what it will do is we will put this P1 again in the ready queue because it still needs to get executed, still needs CPU for execution. So then we will bring P2 in the queue because P2 is here. So we'll bring the P2 from the ready state to the running state. And then again, we will run it also for the 2 units of cycle because of the given quantum is fixed. So if we run it for at the 4th cycle, so it will again become from 4 to 2. That means it only requires now the 2 units of time. Now, if you notice here at the 4th unit of time, the process P4 have also arrived here. So when the process P4 have arrived, we will write it in the ready queue here. And then once the process P4 is there, P2 also needs to be get executed, right? So we will write P2 in the queue here. Okay. So now after this, the P3 will get executed from the ready state to the running state. And how long the P3 will work? So P3 will again work for 2 seconds. And here it also needs the CPU for 2 seconds. So we will just complete its process. So once the process is completed, so you see the process 3 have completed its execution and it will terminate. After that, so in the queue, you have the P1. So we will write the P1 here and then execute it for 2 units of cycle. So P1 is executed for 2 units or 2 seconds. So 1 second is still remaining. And after that, you have the P4. So the P4 will get executed here. Now remember, since P1 still needs to get executed, we will again write P1 at the back of the queue, of the ready queue. So the P4 will get executed. So how long will the P4 will get executed? So you need to add this one, sorry. So it should be 6 and this one should be 8. Let me just erase it and write it for you. So this should be 6 and this should be 8. Now P4 will actually need the CPU only for one duration of time, whereas the quantum given is 2. So you don't have to run it for 2 times because the processor does not require 2 seconds. It only requires the CPU for 1 second. So you only run it for 1 second. And then once you run that process P4 for 1 second, it will terminate. Now the only processes that are remaining are P2 and P1. So what is P2? So P2 is now will get into the running state, and then P2 needs to be executed for 2 burst time. So we will just run it here. So the P2 also gets terminated. And then we have the P1. So P1 will come into this one, and then it will execute up till 12. That means it will only execute for 1 unit of time. So it will get terminated also. So now if you try to see the completion time for the process P1, so the process P1 is 12, whereas the process P2, if you try to see the last time, you have to see the last process where it got terminated. So here it got terminated process P2 and the completion time is 11. Similarly, for process P3, the completion time is 6. And for process P4, the completion time is 9. So based on that, you can also calculate the turnaround time and the waiting time and the response time. And remember, like when we are talking about the preemptive mode, your waiting times and the response times will be different. So I have already calculated these for you. You can go through it and then check and verify these numbers. One thing to remember in the round robin scheduling is, if you notice, whenever a process is running, the process P1 is running, and then it is stopped in between to execute the process P2, because the CPU can only execute every process for 2 seconds. So whenever it needs to do that, it will try to do a kind of context switching. What is context switching? So the context switching is nothing but it will try to save the state of P1 and then reload P2 into the CPU for execution. So this is nothing but your context switching. So the question, there could be a kind of a question where you could, there could be something like, how many times the context switching take place in this numerical? So remember, in this place, you have the context switching taking place here. 1, 2, 3, 4, 5, 6. So total 6 times the context switching is taking place. You will not count the initial one and the final one because it is not counted, because there is no switching happening here. So the context switching happens here for the 6 times. Now the drawback with this round robin scheduling is, if you have a higher Q, that means if you take the Q value to be very high, then it will actually function like a first come and first serve algorithm. However, if you have a Q smaller, then it will try to create an overhead of context switching. Because remember, whenever you have a context switching, you will always talk about the dispatch latency or the overhead. So it will try to create a lot of overhead when your queue is very small. So this was about the round robin scheduling. So thank you, everyone.